There. Okay, so reviewing over all the material that you're going to see, you guys do need to make sure that you know the different kinds of roots. So if I say a square root of 36, you need to make sure that you understand how to be able to plug that into your calculator, or at least that you have memorized what some of those are. Do you guys know what square root of 36 is?
Sorry, I had to use a calculator.
That's fine. That's okay.
6.
6, right? And just if you need a reminder, your square root button, you have to hit that second button first, and you will have the TI-30XS on SchoolNet. You'll be able to have that calculator there, so it's going to be no different. It'll be exactly the same setup. You hit the second button first, and then you hit the X to the second power. That right above it is that square root button, and then you just type in your number that you want, which could be 36, okay? And the reason is because what's 6 times 6?
36.
36. That's the whole reason that it is. You know that 6 times 6 is going to equal 36, so that means that the square root is going to be 6. You also need to be able to do that same thing with cubed roots. So remember, if it's a cubed root, so like a cube root of 1,000. If it's a cubed root, go away. It's my daughter, sorry. If you want the cubed root, it's going to have that 3 up in the left-hand corner of the root. So it's the exact same idea, except now you need to know what times itself again is going to equal 1,000. And what's that going to be?
10, right?
10. Because if you do 10 times 10 times 10, that's going to give you that 1,000. So it's the same idea on your calculator if you have to use that. To do the cubed root, you still have to hit the second button again, but instead of hitting the square root one, you're going to hit the one right above it where it says an X in the corner and then a square root. Oops, sorry. You have to hit the 3 first. That's my bad. You have to hit a 3, then you hit second, and then that little X square root button. So that way it puts the 3 in the corner, and then you put in 1,000 or whatever number it is that you need to find. Hit enter and it'll give you your 10, okay? So there's your breakdown. So you need to know how to be able to find your square roots and your cubed roots. You also need to know how to do some estimation and where something's gonna fall on the number line. So sometimes they're not gonna come out to perfect whole numbers. So if I said something like the square root of 47. So square root of 47 is not a perfect square. So if I said, hey, I want to estimate it. Estimate between what 2 integers? So I want to know what 2 numbers on the number line will the square root of 47 fall in between. So if you take the square root, so hit second square root of 47, it's going to still give you square root of 47. If you hit that double arrow down at the bottom, that's going to convert it to a decimal for you, and you get 6.855 and so on and so forth. So what 2 numbers does that number fall between?
6 and 7.
6 and 7, good. So we know it's going to fall between 6 and 7, somewhere on the number line. You also will have to do an estimation on the number line. So I might give you a 6 here. And 1, 2, 3, 4, 5, 6, 7, 8, 9, and then here's a 7. Okay, so I might have a setup that's similar to this, and then I'm going to say, well, you know, roughly where is this going to fall in between? So if I were to say that this is A and this is B, let's see here. Here's C, and here's a D. And I want to know what letter would square root of 47 fall on. It would be roughly right around here at C, because again, square root of 47 is approximately 6.85. So it's going to fall between 6.8 and 6.9. So you would need to be able to estimate that on a number line. okay?
Mhm.
Any questions about that so far?
No.
Okay, and then can you remind me, do you guys remember what is an irrational number?
When a decimal does not repeat.
Very good. Does not repeat, and it also does not stop. It doesn't ever stop. So like 2.5, 2.5 doesn't repeat, but it stops. So that makes it rational. An irrational number never stops, never repeats. So it's a decimal that never stops and it never repeats. So you need to be able to identify, if I give you numbers, you need to identify, is it rational or is it irrational? So I might give you a set of numbers and you have to identify the rational number, or you have to identify the irrational number. So you guys need to make sure you know how to tell if it's rational or irrational. Irrational is real quick and easy to say, okay, hey, never stops, never repeats, it's irrational, okay? So do you guys remember what's the most famous irrational number we've ever talked about?
Pi.
Pi. Pi. Pi is the most famous irrational number. It keeps going on and on and on. Even though we've estimated it to 3.14, it's actually a number that goes on forever. So you need to be able to identify those irrational and rational numbers. And that's it for roots. Now we're going to go on to exponents. So just talking about the exponent rules and making sure you understand how to simplify a problem with your exponents. So if I give you x to the 4th times x to the 8th. X to the 4th times x to the 8th. What is that going to give me?
X to the power of 12.
To the power of 12. Good. You keep the base. The base is going to stay in x, and all you do is you add the exponents. You're just going to add your exponents. So 4 plus 8 is going to give you 12. Okay. If I gave you x to the 9th and I want to divide it by x to the 5th, what is that going to be?
X to the 4th. 4.
Yeah, x to the power of 4. So again, you're going to keep that base, stays the x, but this time you're going to go ahead and subtract the exponents. So for multiplication, you add the exponents. For division, you subtract the exponents, and it gives you x to the 4th. Okay. If I have x to the negative 6th power, am I allowed to have negative exponents?
No.
No. So anytime we have a negative exponent, we always turn it into what?
Fraction.
A fraction. And what will the numerator always be?
1.
A 1. Good. Does the base ever change?
No.
No. The base is going to stay the same. The only thing that changes is the exponent. What will the exponent become?
Positive.
Positive. Good. So it becomes a positive 6 this time. So you get 1 over x to the 6th power. 1 over x to the 6th power. Okay. And then my favorite one, x to the 0 power. Any number to the 0 power is always going to equal what, ladies?
1.
1. No matter what number you have, if it's raised to the 0 power, it is always going to be equal to 1. It does not matter what kind of number you're dealing with, it will equal 1. Okay, and then the one that we learned most recently, if we have x to the 9th power, and then that's all inside parentheses, and then on the outside we have to the 5th power. What do we do then with the exponents?
Multiply.
Multiply them. So you only have the one base, So that base will stay the same. But now you're going to go ahead and you're going to multiply. You're going to multiply 9 times the 5, and that's going to give you 45.
45.
Okay?
Mhm.
You guys have any questions whatsoever?
No.
No.
I just wanted like extra review.
An extra review? Yeah, it's always good to have an extra review. And if you need, I'm going to post this again on tomorrow's e-class page, the Zoom session, so that way you guys can review over it before you take the quiz. And you can use your notes during the quiz. It's perfectly fine. But this is the stuff that's going to be on the final exam as well. Okay?
Okay.
All right. Y'all have a good day.
Okay, bye.
Bye.
Bye.